Perfect square trinomials are, you could do product sum for these trinomials. But really, if you were to do product sum for this one, 9 times 16, that's going to be a big number, right? 144, 24. I guess you could figure that out, but not too big. But sometimes they do get big. So if you notice that this and this, these are perfect squares, what you can do is you can do a little shortcut and do, it's bigger. You can do the square root. So the square root of 9 is 3. And the square root of 16 is 4. And both of these are pluses, so there's going to be plus plus. Now, you gotta distribute and check your answer to make sure that you end up getting 24 as your middle term, or else maybe it won't work. Okay. So if we look at another thing, let's look at this one. The equal 0 we'll get to in a second, but maybe this one would be a good one because 1 is a perfect square and 4 and 9 are both perfect squares. So the square root of x squared is x. Square root of 4 is 2. Square root of 9 is 3. So that's 2/3. And this is a minus sign, so both of these are going to be minus. And that equals 0 just means that you're going to set these equal to 0 and solve for x at the end. Okay, that's what we're going to get into in the next unit where we graph quadratics. And then obviously add 2/3 to both sides, adds 2/3 to both sides. This is going to give you the same answer for both. So x equals 2/3. And we'll talk about what that means later, why we can solve for x later. And one other thing I wanted to show you quick. Don't forget even with trinomials, you should try to factor out a GCF first. I can divide all these by 3. So that would be 4x squared and then 147 divided by 3 is 49. And then let's see, 2 and 7, 14, 28. I think that's got to be 28. 84 divided by 3 is 28. And then obviously that would be square root of 4 is 7, square root of 4 is 2, square root of 49 is 7, so that'd be 2x minus 7, 2x minus 7. And that 3 is going to stay there.